Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of dilation representations. This is standard 8.3c in the great state of Texas, and we are using item number 26 of the 2016 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got circle 1, it's this smaller one right here. It's dilated, we've got the origin as the center, and it was dilated to create circle 2, which is this larger one out here. So we need to find the rule. So they don't really label in the answer selections of F, G, H, and J, but they say it's circle 1 to create circle 2. So we need to go ahead and label this right here. So C1 is going to be on the left, C2 is a result of dilating, doing something to C1. So that's going to help us as we're kind of looking at those two columns there. So we've got two circles here. We don't have any points plotted, but we can at least eyeball a few of them right here. So let's just go easy. Whenever we can get the x or y coordinate to be 0, it's always super easy. So let's look at this circle 1 right here. So I'm seeing I've got C1 here. Right, so I've got a point that is x of 3, y of 0, right, and it gets transformed to C2, and the dilation there becomes 8, 0. All right, so 8, 0, and we'll, looks like we could do the same thing. Look at this one right up here, right? It just kind of flips the x and y. So it's x of 0, y of 3. It gets dilated up there, and it goes to x of 0, y of 8. All right, so it's a pretty good circle. We could do the same thing with just negatives. All right, so what is happening in each of those? Well, the 0 is staying the same, but that's just simply because it's 0. It's going to be like that because the origin is the center. But take a look at what's happening with the non-zero digits. The 3 is going up to an 8. The 3 is going up to an 8. So it's getting larger. So how do we make something larger? Well, if we multiply by 3 over 8, right? So 3 over 8, let's take a look at that first. That's our F option. So 3/8, that's the problem. It's less than 1. So here's the rule. If you multiply by something less than 1, then you are actually multiplying by a decimal. So if we want to look at it, right, that's 375. So when you're multiplying by something that's less than 1, you're actually going to make it smaller. So circle 1 actually grew larger to become circle 2. So this one is not going to work because that's making it smaller. Now, when we are looking at 8/3, that's kind of a random fraction, but it's greater than 1. So we are, let me see, that's going to be 2 2/3, I believe. 2 2/3, 2.6 repeating. So you're going to multiply, you're going to basically double it, almost triple it. So that's a possibility there. Take a look at these two right here. So these F and G are true dilations, right? Because you're just multiplying the x and the y by something, by a scale factor. But look at this, you're getting x plus 5, y plus 5, or x minus 5, y minus 5. These are not dilations. These are actually translations. You're just shifting it over. You're just taking the exact same circle, circle 1, and you're just shifting it this way, or you're shifting it this way, depending on what you're doing with the x and the y. You're not making it bigger or smaller, right? So if you take your C1 right here, you take your 3, let's take this first set right up here, and we multiply it by 8/3 times 3, 8/3 times 0. Guess what we get? We're going to get that right there. So that's our answer, G.